As shown, two particles, each of charge plus q, are fixed at opposite corners of a square that lies in the plane of the page. A positive test charge plus q is placed at a third corner. What is the net force on charge plus q? All right, so we have a force this way. Due to this charge up here, we have a force this way due to that charge. What's the length of that vector? Well, we use Coulomb's law to find the magnitude of the force. So that would be K times big Q times little q over S squared, because S is the distance between them. That is also the length of this vector over here, K, big Q, little q over S squared. Now, in order to add these together, we're going to end up with one vector that looks like this, right? And so these are the sides of a right triangle. We have this vector here, we have that vector there. This is K, big Q, little q over S squared. And so we need to use Pythagorean theorem to find the length of that hypotenuse. So that is K, Q, Q over S squared, squared plus that again, and then the square root of that. So there we have Pythagorean's theorem, right? C equals A squared plus B squared, and we take the square root of it. And so that is the square root of, and I'm just gonna square everything in here just to see what's going on. So we have K squared, Q squared, little q squared over S to the fourth, plus the same thing again, Q squared over S to the fourth, and we can add them together. So the square root of 2 K squared, Q squared, Q squared over S to the fourth. Now we can take things out, right? So we can, actually I'm gonna do it like this. K can come out, Q can come out, little q can come out, and we have S to the fourth here, so S squared can come out, and that leaves us with the square root of 2 behind. So that is, let's see, square root of 2 times K, Q, Q over S squared. The answer is C.